Let's talk about aldehyde and ketones. Aldehydes and ketones are other functional groups, and you can see that aldehydes has a carbonyl group bonded to a hydrogen. This is a carbonyl group, guys. CO is a carbonyl group. This CO is what? Carbonyl group. If this carbonyl group, at least from one side, is attached to hydrogen, we call it aldehyde. So this is aldehyde functional group. This is aldehyde functional group. Carbonyl group and a hydrogen attached to it. This is aldehyde. This carbon can be hydrogen or can be a carbon. In the and always aldehydes end with Al. For example, when we have one carbon, it's gonna be methanol. What about here? We have two carbon. It's gonna be et, right? It's gonna be ethanol. Ethanol. And here, when we have one carbon, it would be formal. That's the common name for it, formaldehyde. Uh, what about ketones? Ketones are other functional groups. Do you see remember this carbonyl group, right? CO, double bond. This carbonyl group should be attached to this carbon groups. You can see that from the both sides is attached to carbon. Both sides, so this is all together ketone functional group. We should show that we have a ketone by a C double bond O and two carbon attached to two sides of the carbonyl group. This is what? Ketone. Let's see which of these are aldehyde, which of them are ketone. This is what? Aldehyde. Look at here, guys. COH, right? COH. This is methanol or formaldehyde. That's the simplest aldehyde. Here is the trigonal planar, the 3D structure of the aldehyde. Here, what about this one, guys? We have aldehyde. Look at, compare it with your root aldehyde. That's the aldehyde. So you end with Al, is ethanol, right? That's the common name for it in the bottom, all of them. What about this one, guys? This is ketone, right? From the both sides, it attached to carbon. Make sure, guys, even when they show like CH3 like this, always they are connected carbon to each other, because hydrogen is always terminal group. Always hydrogen is attached to the carbon from outside, around the carbon. Is never gonna be bonded from two sides to another element. It's always making one bond, hydrogen. So ketones always end with O and E. For example, here we have three carbon. We have three carbon. It's going to be prop, and they add propan, right? We remove E from it. It's going to be propanone. Propanone. The same for the aldehydes. You remove the E, it's going to be ethanol. I will talk about how we start numbering, guys. Let's start numbering from the ketones, guys. Ketones and naming is almost the same as alcohols. Make sure find the longest chain of carbon, right? So you can see here, that's we just talked about it. This is 1, 2, 3. That's propanone, or the common name acetone. That from the both sides is gonna be 2-propanone. So they just write it propanone. What about this one, guys? Which do you think from which side I should start numbering? I should start numbering from the side that I reach the carbonyl group sooner. So it's gonna be 1, 2, 3, 4, 5, 6. I cannot start numbering from the right. See, if I start from the right, it would be 1, 2, 3, 4. So that would be from the right side, the choice. So it's gonna be, we should make sure emphasize on the carbon that has a carbonyl in it. The same as with alcohol, right? So it's gonna be, or even when we talked about amines, we should emphasize on the carbon that has an amine on it, right? Is the same. So it's gonna be, first we're gonna talk about the branches, right? Make sure branches should come alphabetically. 5-methyl, right? On carbon 5 we have a methyl. 3-hexanone, right? And with ONE. On the cyclose, we start from the carbon of carbonyl group for sure, right? 1, and we should start from the side that we reach the branch sooner. 1, 2. It's gonna be 2-methyl cyclohexanone. We don't need to emphasize on 1 because we know that we start 1 in the cyclohexanone or cyclose. Let's talk about naming of aldehydes. Aldehydes are really easy, guys. You're gonna first find the functional group, right? That's aldehyde. That's very important, guys, that you can be realized if you have aldehyde or ketone. It might be a little bit tricky. Make sure make a flashcard of aldehyde and ketones. Even you might get mistaken it with the you might mistake it with the alcohol, you know what I mean, if you don't have enough practice. So make sure make flashcard and write their functional group to be able to recognize them. So we said that we remove the E from the alkane and we add AN, right? So for the aldehydes, again, we should find the longest chain, the same, but we should start from the carbonyl group always numbering. Again, we always start in aldehydes, start numbering from the carbonyl of aldehyde, always, no exception. Okay, if for sure, if my parent is aldehyde, that's very important. If my priority is aldehyde. So here we start from the aldehyde C, right? 1, 2. 1, 2. You do not need, guys, in aldehydes, write the carbon of carbonyl. They're like the number on the carbonyl group in aldehydes because it's always 1. Because we start always from carbonyl of aldehyde. Let's do the second one. So we find the longest chain. We know it's aldehyde, right? COH. One side of carbonyl attached to hydrogen. Longest chain of carbon. We start from which side, guys, numbering? From the carbon of carbonyl, right? 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. It's 5 carbon. It's gonna be pentanol. We don't need again to emphasize on the carbon of the number of carbon of carbonyl. You know what I mean? We don't need to say 1 pentanol because we already know that always in aldehydes start with 1 carbon, 1 from the carbonyl group of aldehyde. Whenever we have a cyclone attached to aldehyde, is a little bit gonna be different naming. It's gonna be cyclohexane, basically carbaldehyde. So whenever you have a cyclo and you have an aldehyde attached to it, it's gonna be carbaldehyde. Okay, so it's gonna be cyclohexane carbaldehyde. So this is carbaldehyde when you have a cyclo. Okay, whenever you have a double bond and aldehyde, do you think which one is a priority? Do you think which one is priority? The aldehyde. So you can see that that's a priority table, that which one is more. We said that carboxylic acid the most prior, right? And there is a suffix name and prefix name. So when you get the aldehyde, and this is alkene, right? Which one is most prior? Aldehyde. So we're gonna end, the parent name would be aldehyde, or root name will be aldehyde. And it says here that if you have unsaturated aldehyde, you're gonna, instead of write the pentanol, you put pentanol. You just put all the double bond and the aldehyde together. It's gonna be pentene. Do you remember that would be pentene if there was no aldehyde? But we remove the E from end of pentene and add AL. It's gonna be pentanol. And of course, we should emphasize on the double bond, right? It's gonna be 3 on carbon 3, 1, 2, and 3. On the carbon 3, I have a double bond. It's gonna be 3 pentanol. And here is a trans. If they ask you to write it down, it's going to be trans 3-pentanol. Okay, what about when we have aromatic compounds? Whenever, guys, you have a benzene group, do you remember that's a benzaldehyde, right? Whenever we have a CHO and it is a benzaldehyde, then if you have uh, other groups attached to it, you should make sure that which one is priority. Again, if you go back to this table, you see that aldehyde almost is on top. Aldehyde, so all of the alcohols, alkene, alkyne, alkanes, amines are below this. So again, if we want to name it, is going to be starting from the CHO. So, and because if you remember, that's the benzaldehyde, and because it's the priority, we should name it based on the benzaldehyde. We start from right side. Why? Because we reach the branch sooner. It's gonna be 1, 2, 3, and 4. It's gonna be 4 hydroxy, 3 methoxy, benzaldehyde. This is vanillin, guys, that uh, we have the we get it from the vanilla beans and is used for add as a essence in the food. Whenever we have more than 3-4 carbons, in different books they kind of sometimes they say 3 or more carbons, sometimes they say 4 or more. You can both of them write you can make sure would be the longest chain, and this would be as a branch. We talked about that would be phenyl. On carbon 1 I have the aldehyde, so it's going to be 1, 2, 3. On carbon 2 I have a double bond. So on carbon 3, I have a phenyl group. So it's going to be 3 phenyl. On carbon 2, I have a double bond, 2 propane, right? 2 propane. And because I have an aldehyde, it's going to be 2 propanol. And because this is a trans configuration around the double bond, it would be trans 3-phenyl 2-propanol. Let's do some practice and name these compounds. What do you think is the first compound? Is it aldehyde or ketone? It's ketone, right? Because it's connected, this carbonyl group is connected to carbon from the both sides, right? So we're gonna find the longest chain, and it's gonna start numbering from the right side. It's gonna be 1, 2, 3, 4, 5. So we have 2 pentanone. On carbon 2, we should emphasize when we write the name. On carbon 2, I have a carbonyl group, 2 pentanone. What about the third one? What about the second one? Second one is aldehyde or ketone? Is ketone again. So we find the longest chain. That's the longest chain. We start numbering from the right side. 1, 2, 3, and 4. So it's gonna be, first we should write down the branch is 1, 2, 3. 3-methyl 2-butanone. The third one, we have a cyclo here, cyclohexanone. We start from a carbonyl group. We start numbering from this group, and it's gonna be 1, 2, 3, 4, 5, and 6. So we start numbering from right side because we reach the branch sooner. And when we write a name, it's gonna be based on alphabetical order. 2-bromo, 5-methyl cyclohexanone, because it's ketone. In this one, we have aldehyde or ketone. We have aldehyde. See, here we have COH from one side is connected to hydrogen. This carbonyl group is connected to hydrogen. So we have 2 aldehyde groups. We find the longest chain. The longest chain should include the carbonyl groups. Then is going to be on carbon 2, I have methyl group, 2-methyl, propan, because it's 3 carbon, propan diol, because these 2 aldehyde, I should mention it in my when I name it, propandiol. It doesn't matter, guys, here which side we should start with, because it's the same, it's gonna be the same numbering. You can try it yourself and you can see that it's gonna be the same numbering. What about this one? Find the longest chain. That's the longest chain. Is it aldehyde or ketone? Is aldehyde, because one side is connected to hydrogen, right? This carbonyl group is connected to hydrogen. We start numbering from the left side. If you remember, we said that we start numbering from the carbonyl of aldehyde when we have aldehyde. So it's gonna be written based the branches based on the alphabetical order. 1, 2, 3. 3-bromo, 2-methyl propanol. Propanol, because it's aldehyde. This is aldehyde or ketone. This is aldehyde, but there is another functional group here, which is OH. So whenever you have two functional groups, you go back to the table we talked about. In this table, we're gonna have the aldehyde, we find the aldehyde, we find alcohol. You see that aldehyde is higher compared to alcohol. So my parent name or my root name would be based on aldehyde. So it's going to be, my parent name will be based on aldehyde. So my longest chain of carbon, we should make sure should include the aldehyde functional group and also the carbon that connected to OH. Then it's gonna be 4-hydroxy because my OH is not the root name and it's just the prefix. We just use hydroxy here. So on carbon 4, we have hydroxy. Why we numbered from the right side, guys? 1, 2, 3, 4. Because we should number from the root name, which is aldehyde here, because it's more prior group. 4-hydroxybutanol. In here, we have also two functional groups. Here we have alkene and here we have aldehyde. Which one is more prior? Aldehyde is more prior. So I start numbering from 1 here. 1, 2, 3, 4, 5 is going to be 3 because on carbon 3 I have a double bond. I should emphasize on it. 3-pentanol. As I said, you do not need to emphasize on the carbon or carbonyl on aldehyde because we always start number 1 on aldehydes, carbons. So what about this one, guys? Here we have a phenyl group because I have a 3 carbon here. My benzene ring would be like a branch. So it's gonna be 3-phenyl propanol. Here again I have ketone and another functional group which is alkene. Which one is more prior, guys? Ketone is more prior. From which side I should start numbering? From the left side because I reached the alkene sooner. So 1, 2, 3, 4. So if you even start from the left side, 1, 2, 3, 4, both of them from both sides will be number 4, the carbonyl group. So we should start here from left side to reach the branch and this alkene group or the functional group sooner. It's gonna be 3-methyl, 2-heptene. On carbon 2 I have a double bond and it's gonna be 4-on. Even you can, another name will be, you might see when you do more practice in some website, you might see 3-methyl, 2-ene. They just use the N part of alkenes. 2-ene, heptanone, 4-heptanone. You might see also the name that I said. That's it, guys, for these practices.